Oh, hi. What? You want an episode of Knowledgeica? What now? Well, okay. How about, how do headphones work? Yes. How do headphones work? Woo, roll titles. Hi there, Danny Ward here. This is Knowledgeica, the show about anything and everything. Today we are looking at headphones and earphones. Just think about it. It's kind of crazy how a contraption relatively small can produce some of your favourite tunes and in many cases pretty near identical to the original recording. How do they work? Magic? Nope, not magic. That is science and engineering. Headphones are essentially a tiny pair of speakers on the side of your head. So, first off, how do speakers work? Typical loudspeakers, the ones you'll find in computer speakers, amplifiers, car speakers, sound systems and the like, these all function with a similar principle in mind, using an electromagnet to convert an electrical signal into a sound you can hear. Inside the speaker, an electromagnet, which is located in front of another magnet known as the permanent magnet, will be attracted or repelled based on the electrical impulse. The electromagnet is attached to a cone which moves with it. The repulsion and attraction of the electromagnet and cone in response to electrical signals happens many times per second. This can range from very low to something like 8 vibrations per second to really fast, like 20,000 times per second. We measure this vibration frequency with a unit called hertz. Different parts of the song will output a different electrical voltage to the electromagnet, leading to a different frequency. So how does this vibration lead to sound? The movement of the cone causes molecules in the air to move too. This air molecule movement is what causes the sound. Why? Well, the sound waves from the movement will travel to our eardrums, which will then vibrate in response to this. This is converted and processed in our brain, where we will interpret these vibrations as sounds. A speaker will have a wide frequency range over a very short time, and as such can recreate sounds incredibly well. Poorer quality speakers that may have a limited vibration frequency range, or speakers that are subject to interference or poor connections, may lead to static, noise and inaccurate audio recreations. Different speakers are able to produce different vibration frequencies and thus different audio ranges. This is why many home cinema setups have multiple speaker types connected to different channels. A subwoofer will hit the low frequencies. There will be speakers designed to hit mid-ranges, and then there will be a speaker called a tweeter which hits the high frequencies. What we have just gone over there is called transducer technology, the conversion of electrical signals into sound. While, admittedly, this does sound something not out of place on a 1960s Star Trek episode, the transducer is far from science fiction. It's just good engineering. So, back onto headphones. How these tiny speakers operate is very much dependent on the type of transducer technology they use. This is very dependent on which headphones or earbuds you go for. There are a variety of types which all use different methods of converting electrical signal into sound. The major types of transducer technology within headphones are moving coil, electrostatic, electret, orthodynamic, balanced armature and thermoacoustic technology. There are other minor types too, such as magnostriction and plasma ionization, but for now we'll focus on the main types. Moving coil, also known as dynamic, works by producing a static magnetic field from a stationary magnet. A light coil of wire is attached to a fabricated membrane. This duo will vibrate in response to variable forces exerted from the magnet in response to electrical signals. Just like a conventional large speaker, this vibration vibrates air molecules, this time right in the ear canal, to produce sound. Electrostatic transducer headphones have an electrically charged membrane in between two metal electrode plates. Depending on the electrical signal, the membrane will be drawn to one of the two plates. Repetition of this leads to the sound producing vibrations. Sensing a theme here? These electrostatic headphones are often seen as ones which offer some of the highest audio quality, as their design allows for a high vibration frequency response. Electret are essentially extensions of electrostatics. They are virtually the same, however the source of the electric charge is different. Electret transducers have a built-in system. The charge for electrostatic transducers is from an external generator. The next type of transducer, orthodynamic, are similar to electrostatic headphones. However, their vibrating membrane contains a wire mesh pattern. It's this wire mesh which is attached to the two electromagnets. The final two main types of headphones are balanced armature and thermoacoustic technology. Balanced armature does sound kind of like a military order, but what it actually means is that these headphone types work by having a pivoting moving magnetic arm which will move a diaphragm in response to electrical signals. This design requires less power than many of the other methods, and we're back to military again, but this time for real. These headphones were popular during World War II for military telephones. Nowadays they are more common for in-ear headphones and hearing aids. Thermoacoustic headphones are the odd ones out here. These ones don't use magnets. Yes, really hard to believe after how popular they seem to be with the other ones. Thermoacoustics work by using hot nanotubes. Ooh, sounds sciencey. As these nanotubes heat and cool in response to an electrical signal, they produce sound waves. A really neat system, and due to the lack of moving parts, could very well last much longer than traditional headphones. For now though, these are headphones of the future, as they are still in the research and development stage for now. Pretty interesting stuff, huh? Now, before we finish, a little extra bit of knowledge I found quite interesting. When new headphones are being developed, how do you think they test them out? They don't just go and sit in a quiet corner of a library. No, they take it one step further. Anechoic chambers offer a room completely free of any sound echoes. All sound reverb waves are completely absorbed, giving a truer depiction of the sound the headphones can really produce. Sounds like it could be a great place to grab a nap, although saying that, more than 45 minutes can supposedly drive you a little crazy. You can hear your heart beating, your lungs contracting, and your stomach sloshing its juices around. Yeah, I can see how that might be a tad unnerving. That's all for today. Thanks for watching. Those things you might be watching this video with, quite a neat piece of engineering after all. Please do give a thumbs up if you enjoyed the video. Subscribe if you want to see more, and don't forget to follow Knowledgeica on social media to get all the latest updates and behind the scenes insights. Until next time, stay hungry for factuality.